Hello, my name is Rod Kowicki. I'm doing this second video on the black box universe. Why I call it the black box is because that's what happened when Einstein wrote his two theories on general relativity and special relativity. Special relativity in 1904. In 1915, he published a work called General Relativity, 2 books. 5 papers and 2 books. It all happened within the early 20s, 1920s. Anyways, we still rely on these studies today. Very little has been expressed since that day, and nobody has exceeded the speed limit. There's only one thing that goes faster than light in this universe. And in 1947, a man named Edward Hubbard, looking through a telescope, measured and discovered that the universe was expanding, and that it was expanding faster than light. Now, the universe is expanding FTL, faster than light. Light is slow compared to the universe. The universe is getting bigger. And Einstein, in 1904 or 05, published a work saying, I wonder what it would be if I could travel on a beam of light. And he wrote some theories that put our whole world and our way of thinking in a black box. That's what happened. What you're to hear now is going to take us out of this box, because that's the way it works. Now, Einstein's theory on general relativity was the fabric of space. Special relativity was time and space. What's time have to do with space? Einstein said time and space are the same thing. One can't do without the other. And it's all at the speed of light. Now, the contradicting argument is, no, it's no longer that way.
The time is 9 p.m. The time is 9 p.m.
Yeah, I heard you. Anyways, space is expanding, co-moving and expanding at a faster velocity than the speed of light. Light is being left behind. Light goes back to its original origin, signal communications. We can't send a signal faster than the speed of light. That's how fast, that's not only how fast energy travels, but light waves travel. Alpha and beta waves travel back and forth, according to Einstein. Alpha waves into the future, beta waves back into the past. And that's how energy is conserved in his universe. It's no longer our universe. It's his. We can receive information from the future, which was his theory, and we could send information to the future from the past. From the past. These are the past. I think everything works on a second. Not a second, we measure things in seconds and tenths of seconds and stuff like that. I think that's how it works. Einstein said, no, that's not how it works. When you travel the speed of light, you travel into the infinite future. Every second you travel, you go into the future. Because everything at the other end is going really slow. It takes time from one to get the other, but it's supposed to be instantaneous. So, I don't know how he figured that out. Instantaneous time, that's what he called it. if you travel faster than the speed of light, then we go back into the past. Well, that don't exist no more, from what this video is telling you. The universe is expanding at a rate faster than light. Faster. That means we can travel as fast as gravity can. And there's no dead end. There's no flat space in it. Well, he says there's flat space. I think it's round. And I don't, his round is a flat pancake universe. Mine is round basketball. It's twisting, turning. The universe is in the same space that we're in. Planets and stars spin, galaxies spin, and they're all in this universe that also spins. If it didn't spin, there would be no momentum because everything would be at rest. So when we look at the facts, the planets and the suns and everything that are inside this galaxy are only moving because the galaxy is moving. And the galaxy is only moving because the universe is moving. And the universe is only moving because space is moving. How are them ducks in a row, right? Now, we got a ship that's able to travel up to the speed of light. It travels faster in space. E no longer equals mc squared, or c over v, only at the molecular level. But at the hydrogen level, outside the shell, outside of the molecular structures of all mass, where we become beings, intelligent beings, out there in that space, things move faster. Now, I don't think there was a Big Bang. My idea is the universe collapsed. Whatever it was collapsed. And I got reasons for that, why it collapsed and how it evolved. And some idea of why it evolved, And when it collapsed, it acted like an explosion, but more like an eruption. Eruptions and explosions are different, but mainly an eruption is something in slow motion, and an explosion is something that's definite. It's got a bam, and it's got an end where everything just, whatever it was, is destroyed. An eruption is like a volcano, just keeps making something, So if we look at the universe, not as a Big Bang, but as let's say, a volcano, everything is still in motion. The universe is still in motion. It's getting bigger. If we look at it like film, it's still going in slow motion. Even though it's fast, it's going faster than what we can coordinate. It's going faster. We can't measure it. But now there's a way to measure it, I think. But Edwin Hubble did. The universe is expanding. It's getting bigger. It's still in motion, is what I'm saying. So what we believed to be a Big Bang was actually a collapse. It collapsed and started in a chain reaction that hasn't stopped. And how it stops and when it stops, guess what? time's going to catch up with whatever it is. You know. Well, you know, we can predict different things. You know, the universe is expanding, is orbiting in space. In the same way a planet is rotating, the galaxy is rotating, the universe, all the masses and everything in the universe is doing the same thing. It's all in a space that making it turn, make it orbit, spin, making it spin. So as long as that's still happening, you know, we're still in fairly good shape because that's the way it's been happening. But when that stops happening, when the universe reaches a point to where it's no more expanding, and it's reached a definite point, then we're going to catch up with it. We're going to catch up, and when we do, it's going to put a limit on things. But that limit ain't happening now. It ain't going on. The universe is expanding. 42.3 miles a second every 3 million miles. You know, do the calculations. I did. I got the math. You know. And what's that mean? You know, what's that mean? The speed of light no longer is a speed limit. That's what it means. It means the universe keeps evolving and we can travel as fast as it's expanding. We'll never catch up because it's moving. We're stuck somewhere way in the past, in the past. You know, calculated at 8 billion light years in the past. It's more than that. I think it's a lot more than that, you know. You know, in 1947, when Edwin Hubble was looking through that telescope and told Einstein, come here and look at this. The speed of light ain't constant. I mean, but Einstein already had all that stuff written. Everybody was accepting it. And in 1947, the radio barely came out. And they was talking good about Einstein, so that never changed. You know, and it takes one person somewhere, like me, is going to tell you different, you know. You know, we are no longer stuck in a black box universe. We got places to go. Our world is getting very populated. We got to go someplace else. You know, that other planet, that other Earth 2, they call it, it's bigger than Earth, but it's got all the whole solar system's got a likeness to our solar system, except it's bigger. It's way bigger, you know. So it's in a space where its expansion is way ahead of us, I think, you know. But still, its gravitational pulls, you know, relevant. You know, I don't know how the gravity would be over there. They'd have to figure all that stuff out, you know. And the reason for this video and some of the things I've been telling you is I'm writing another book, an e-book. I've written 4 or 5 books on faster light space travel. Anything that goes into space can travel faster than it's made to. And that's just based on the vacuum, you know. If it's able to travel at the speed of light, it's going to go faster. And now, all those books are relevant because we can travel faster than the speed of light. And we don't go into the infinite future. Time doesn't change. There's no time dilation. None of that. Everything that happens to mass in a gravitational field like Earth. It doesn't happen in space because energy is 0-point energy. There's no energy in space. And I got an idea why there ain't no energy. And all this is going to be in my next book. But for tonight, I'm just letting everybody know, and I hope I'm, this complicated stuff. It's not easy to think about this stuff. You gotta think over and over again. And this is out-of-box stuff. This is not stuff you learn in the university out of books, because you're going to read that book and you're going to learn it, and you're going to say, yeah, that's the way it is, yeah, that's the way, and it ain't the way it is. That's thinking outside the box. That's not the way it is. And the problem is nobody's allowed to, or don't know what to do with that information when they're out of the box. It doesn't work. And problems arise. But anyways, we can travel faster than the speed of light. And nothing's going to happen. E no longer equals mc squared over v. The E equals mq parentheses 2.7 over c parentheses. That's a new equation for jet propulsion in space. We can travel a lot faster than the speed of light, and we're not blocked in by some flat universe, Anyways, my name is Rod Kowicki, signing off, and I hope you like my video. Thank you.